Hey everyone, we're now at the part of the course where we try to implement our trading ideas with an algorithm so that we can find a way how we can systematically make sure that how we want to trade actually is how we do trade. With that, I want to introduce one more tool that we use in algorithm development, and these are so-called flowcharts. Now, what is that? Why do we use flowcharts? Really what it is at its core, it is a way for us to try to think ahead, to try to conceptualize our logic so that we have a development of the logic of the code, and we can also find flaws in what we have been doing. Now, in some sense, I try to get you to do this when I ask you to explain very carefully what it is that you have to do in order to make your particular trading strategy work. And now what we need to do in order to use this for a code, we basically use the same idea, except that we're trying to be a little more systematic about it. So now let me introduce you to the standard components of flowcharts in course. So there are, standard features and standard portions that people use in order to write this. But we're not going to be religious about it, but I just want to give you an idea of how this normally works. So it all begins and ends with something, right? So when you start your code, you have to have a mechanism by which your code will begin and conditions under which it will stop running. Then you will hopefully involve some comments. So you write your code and you describe at each line what you're doing. We're not going to spend much time on this, but this is something that usually you find when people really develop and think carefully about their code, what's there. You will have processes. In many cases, these will be items such as submit orders and so on and so forth. Then there will be if statements or conditional statements where if one thing happens, you do one type of activity, and if something else happens, you do something else. And then finally, there's so-called input-output. So there is, something could be written in an Excel spreadsheet. It could be an announcement made, whatever it is that your code is doing. Now these are, you see these color codes and you see certain ways of how these boxes are formed. This is to be consistent in the way how you think about a piece of code so that you actually know what to implement. And so a good code has multiple components. It has a design component and it has the implementation component. The design component is really the hard part. The implementation is really more the annoying part, right? So thinking hard about getting the concept for a code right is really very crucial. So let me give you an example for all this. Let's go back to our VWAP. Now, what was the VWAP? Was the agency trading case number 1. And what we tried to do at that point is we tried to trade in a very liquid market 50,000 shares of a security over an entire trading day in such a way that we would match the VWAP. Now, as you know, prices in markets cannot be predicted, in particular not in the programs, because it's programmed to be a random walk. But volume patterns are persistent. And so the first step that you had to do was to estimate the volume distribution. Now, I'm not going to go through the details of how this goes, but I want to remind you that there was an Excel spreadsheet posted on Canvas that you could use for that. If you did it, you could have put in one volume, you had the time, and another volume, in another column, you had the volume. And then if you plot the whole thing, you get essentially a volume distribution, which is U-shaped. Now, this is the number of units that have been traded. A distribution is really something which has probabilities, or if you want, fractions traded. So all that you have to do is you have to compute the total volume, and then for each of the volume entries, you have to compute what fraction of the total was corresponding to that volume number. So I'm showing you here just how this would look like in an Excel spreadsheet, and how you see here. You can see again, this is of course the same pattern of volume, except that it's expressed in percentages. Now, what you want to do is you want to use that information and apply it to your own trading strategy, which is that you want to trade the 50,000 shares. So with that, all that you have to do is you have to multiply the percentage number of volume with 50,000, and that gives you how much of your volume of the 50,000 you should trade in each of these time intervals. So from 9:30 to 9:40, from 9:40 to 9:50, from 9:50 to 10, and so on and so forth. So if you compute that correctly, then you will get some form of distribution which looks again U-shaped, because it matches the volume that we would kind of expect to happen in the trading case. And so it tells you that, for instance, you should trade roughly 6.5% in the first 10 minutes, which accounts to roughly 3,322. So now this is essentially what you have here. Is you have a mapping from time to volume that you want to trade. right? So this is the key part, it's the key conceptualization to determine what it is that you actually have to do. And now you want to think of a way how you can make a code do this for you. So how is that going to be done? Now, fundamentally, what does the code have to do? The code really has to do one thing only. It has to take a specific size that you trade at a specific time, right? It's the mapping from time to size. That's what we're after. So let me show you one example of how you can think about this. So what you really are doing is you're going through a trading day, and every 10 minutes you trade a particular quantity, right? So this is the mapping from time to volume that you're after. Okay. Now let's just think for 1 second. Now, obviously, we're not trading 6.5 hours in the case. We're just trading a representation of 6.5 hours. So now the case in its entirety is 300 seconds long. So it means that 10 minutes of these 300 seconds account would be 7.7 seconds. Okay, so 10 minutes of a trading day correspond to 7.7 seconds in the case. Okay, so what that really means is that every 7.7 seconds you submit a trade. And what you want to do is you want to therefore have some form of internal counter, for instance, where every 7.7 seconds you do this trade, right? So the start for that would be, in this case, for this code, is you basically start the code when the trading case starts. There's other opportune possibilities, but here in this particular case, because you have an internal counter, you are in charge of that procedure. And then what you do is you take 37 times you're doing the same thing. So you have a counter which counts through 39 times. Now, again, what you want to do is you want to have a mapping from time to volume. Okay, and so what you're doing is you count each of these entries. So you have the time entries and you have the volume that you want to trade. And so you basically go through, and at time 1 in my first interval, which is at the very beginning, you trade 3,322. Then you move on to the next interval, which would be from 940 to 950. You trade 2,707 shares. And you go on and on through the entire trading day this way. Okay, and so you make all these submissions, and once you reach the final trading interval, the trading time of the case will also be done. Because here's the trick that you do is you basically do your trade, and then you have the computer wait for 7.7 seconds so you can move on to the next trading interval. So this is basically a loop that you run through. Once you've done it 39 times, you stop. The program stops by itself. Also, the trading case will have stopped by that time. And that's it. That's basically how you would do this.